Hello, Tom Elmog here, and with me is Dishant. Dishant is going to give us an introduction and a quick onboarding to Insight and Analytics. This is Dishant last week, unfortunately, but this is going to be his official knowledge transfer. Dishant, stage is yours.
Yep, let's start. So this is the onboarding document, what you're seeing on the screen for all the Insights team. It consists of engineering as well as the analytics arm of the Insights team. And starting this document, we are going on the process overflows. We have various processes for software development, which most of the developers are aware, but when you are onboarding a team, we expect all the developers to go through the processes on how do we scope of project, how we create tickets, how do we prepare, and then obviously there is a development cycle. How do we create feature branches and PRs and approvals, QA, and then merge and deploy. So that is the first section on the process and workflows. Then there's definitely a technical review checklist when we have a new tech initiative, which are very rare for the Insights team. But whenever we do, and we want to discuss it with the larger team, we have the checklist to go through. And then we move forward from that part. Experimentation Insights team, at least engineering part on the Insights team is not involved in the experiment, like A/B testing or STF or SEM. But this is a section we included for the analytics part because they are involved in that process as well as it is always good to have an understanding of how the experiments are designed, how do we implement them, and what are the post-experiment processes, and how do we even check on the results. And next section is the calendar, is very self-explanatory things. How do we create calendar invites, and what are the recurring meetings and all that stuff. The next section on this document is all the tools which Insights engineering and analytics both use. Jira is basically our workflow product which we use to run our Agile. We are currently in Kanban, so we create tickets, distributed tickets, and then they have daily stand-ups where we get the updates and discuss any roadblocks, as well as we have grooming meetings bi-weekly where we go through any new tickets or any new work expected in the coming sprints. Right, the conferences where we have all our documentation. Then there is Google Sheets. We Spokeo, we use heavily Google Docs and Sheets, and then either Google Drive products. So generic idea of how do we use it. Google Analytics is our primary tool for web analytics as of now. And it is the responsibility of the software engineer on the Insights team to kind of have that integration between Google Analytics and Spokeo Web App, always up and running. I mean, it's always up and running, but if there is an issue, if the analytics is coming in and telling us that, hey, we are seeing some issues, there is a discrepancy or there's a change in the trend, then we have to figure out if there is an issue between the pixel we have deployed on the web app through Google Tag Manager, which is the next section. We have a very detailed documentation on Confluence where we discuss how when we have to implement a new tag or pixel for affiliate partner or marketing vendor or any other pixel, how do we actually create a new feature workspace? How do we add it? How do we ask for the approval? How do we deploy it? But basically, Google Tag Manager, we use that to have so that we can decouple the tag management and the Spokeo Web App deployment cycle. Otherwise, if we don't use Google Tag Manager, then we kind of have to deploy the pixels directly, or we have to embed the pixel code directly onto the Spokeo Web App code. And then anytime we have changed the code, pixel, we have to go under deploy. So Google Tag Manager is a great tool for the Insights team in terms of having that separation between the web app code and then all the other marketing integrations, right? Then we have Snowplow. Snowplow is an open source tool, open source framework, which we have used for our traditional data collection from Spokeo, both in front end and back end events. Now, this framework we implemented back in the day, and the framework we implemented is a little bit older. And also it's very rigid. That particular version of the framework is very rigid. And anytime we have to make an update, we have to make an update on the web app. We have to make an update on the pipeline. We have to update the data hosting tables on Redshift. So it is very inconvenient. So that we are now having our own in-house framework to collect the data. And we are currently in the data validation phase. Once the data is validated and everything, we will deprecate and remove all the Snowplow related code. There is already an epic, all the work has been drawn out on Jira. We're just waiting for the data validation part. Then Tableau is a tool we use on the analytics part for any BI or dashboarding work. Engineering doesn't have to look into Tableau. We just provide data sources and tables or any other data sets needed to feed those Tableau dashboards. But other than that, we don't create dashboards on the engineering side. Then Redshift is our data warehouse as of now, where we host all the data collected through Snowplow framework, both for front end and back end, as well as we have other tables which are coming from Spokeo ETL code base, which are basically data pulling in from different APIs, which is attribution data or conversion data, or we do have other ETL which goes into the Spokeo's backend databases, and then web apps backend databases, and do some transformation and bring the sanitized data into Redshift for the analysts. Now, Databricks is where we have our new pipelines for our data lake, which is our solution to our traditional data collection, which was Snowplow. Now we have our own data collection framework, but once that data lands into our S3 bucket, we massage that data, transform them, and then refine it at different levels through Databricks, which is basically a Spark provider, where you can create on your own clusters. You can schedule your jobs, right? You can also have notifications as well. But where it is the platform where we can actually manage all that post-processing of the data. AWS, all the developers on all the teams must go through this AWS VPN setup, because all the services in the feature and the QA environment for Spokeo is behind the VPN. So that is a must to have. Keeper is another tool which we use for to share our passwords, which is very self-explanatory. There is a guide how to set up Keeper, and then there are the tools which the analytics or engineering side doesn't work directly on, but those are the tools which are where we use on different teams at Spokeo. So and then we have to deal with that data. So it's good to have that idea that these are the tools where we are using for marketing and different.
Let's take a little break from the tools before we jump to testing frameworks. Can we maybe jump into the architecture? I saw a link there on the top. I'm not sure if that's the most updated one. It was under Snowplow, or is the one that we shared last time. Let's talk about kind of the architecture and decisions of the data flow. How is it going from the web all the way when we can see it in reports?
Sure. Yeah. So let's go to the analytics architecture part real quick. Which part of this?
The bottom one? Okay.
We have our the other one is basically our new collection which we have to go through definitely. All right, that's the homepage. Good. All right, so as I said, Snowplow, we currently use Snowplow, which is an open source framework, and older version. We have very thorough documentation on it with the architecture diagram, of course. But basically, if we look at the architecture diagram, what we do is we have used Snowplow framework through two different gems, right? One is Insight Service gem, which you can see over here in the architecture diagram, and then other is the Stats Tracker gem, which is which you can see over here, which is on the backend side, right? So basically, Insight Service gem, there is a JavaScript module within this gem, and then also a Ruby module in this gem. We kind of hacked this, and which is very not frowned upon solution, but it's a legacy code, and we are currently maintaining it. This gem is going to be deprecated once we move towards Data Lake altogether, but currently, as it's a legacy code, we maintain it. But basically, what it does is when you go to Spokeo.com, right? Basically, this gem is gonna push in some JavaScripts, basically, which will have event listeners for clicks, page views, and scrolls, right? And then whenever those event occurs, it will send the data or those events to API gateway, as well as there is a code there is code for send those events to Google Analytics, as you can see over here. But this is an older implementation. We are not using Google Analytics data coming from the Insight Service Gem. We have deprecated that, so you can disregard that. We are now using Google Analytics data collected from GTM tags. But in the older architecture, we used to push that into Google Analytics through this gem on this JavaScript, right? So once we push this data into the API gateway through this JavaScript module of Insight Service Gem, the API gateway will invoke a Lambda function. The reason we have Lambda function in place because the framework collects the data in a particular manner, right? It's a complex nested JSON, and then also it encrypts the data in base64. Encode the data in base64, and some of the extra data which are not part of the actual framework guideline, right? Or framework structure, it's been encoded in one column or one key of JSON. And then pushed into the API. So in order to translate all that nested JSON to a flattened table at the end of the pipeline, we kind of have using this Lambda function to decode the data and then parse out the JSON, flatten it out, and then push it to the Kinesis stream, which is the input stream. And then once the input stream gets the data, it buffers it and then push it out on the Kinesis Firehose. And Kinesis Firehose, after a certain time, it will copy the data which it has pushed on the S3 using a copy command on the Redshift table, right? Now, the Insight Service Gem collects the front-end events, and those are pushed out to the table called Snowplow on Redshift, Snowplow data, which is, if you go into the environment and the reporting database, you will see in the public schema, and in tables, we will see Snowplow data, right? This is a table where we are getting that data coming from, and it has a lot of different columns. It hosts a lot of different kind of events, right? Other than just page views and clicks and scrolls. Connection at Windfield. Not connected. But yeah, once you're on VPN, you'll be able to query this table. That's where the data goes from this pipeline, right? API Gateway, Lambda, Kinesis, Firehose, S3, temporary storage, and then from S3, it will copy the data to Redshift. Now, Insight Service also has a Ruby component, and that component is used to collect some backend trackers as well. And those trackers are also pushed onto the same pipeline and will be part of Redshift, which is all explained in this documentation, right? It will be really hard for me to go through each tracker, but basically a generic idea is anything which is coming from Insight Service Gem will go at the end of the pipeline, will be landed on this Snowplow data, right? And then for the backend part, which is a Stats Tracker gem, which is another gem we have, when the Spokeo user comes in, say you're looking at Spokeo.com, it will make call salsa, it will go to the Rails application, and then from Rails side or Ruby side, we have controllers. Within the controllers, developer can define what kind of tracking they need for a particular event, right? These are some examples of those events. For example, email search results. For example, if you're looking for email on Spokeo, right, that will eventually invoke one controller responsible to handle that email search. And now that controller is going to create this email search result tracker, and it will use Stats Tracker gem to create that tracker. It will add all the other event attributes, basically, for example, what email ID was searched, what was the user session ID, their client ID, what was the page URL, any other details which we have, which we thought was important for that tracker. And then that gem is responsible to bash those trackers in the set of 3, in the batch of 3. And as soon as the buffer is full, it will push that bash onto the Kinesis input stream. For the backend trackers, we don't have API gateway or Lambda function here. We just push it directly using AWS Kinesis SDK. We just push it out on the Kinesis stream, which is the input stream. Once the input stream buffer is full, same thing, it will go to the Firehose, which is the output stream. And then from Firehose, it will use the S3 as a temporary storage and then push out the data onto the Redshift through the copy command, right? Now the stats tracker table, stats tracker gem will push out the Redshift data into the Redshift on a different table. It is called stats tracking data, which is this table, right? Now, the caveat of this implementation is you can see the name of the columns, right? Field 1S meaning the first string column, second string column. Similarly, after 25 strings, it's limited. After 25 strings, there is first integer up to 10th integer, then the first time column, first Boolean column, right? Now, this is very generic implementation of the tracker, meaning each tracker, regardless of their name or type, all these trackers are going to be pushed out in this table, and the way you filter out is basically through their name of the tracker. Now, all these columns are generic, so you don't know which column is hosting what, right? So now then the developers back in the day, they created another Confluence page for the stats tracker usage, which is this page, right? So for example, that email search tracker, if I can find it here. Maybe that tracker is not there anymore, but let's just use any example, right? For example, phone search. So if you want to see, if you're querying that table, saying select star from snowplow data, stats tracking data, where name tracker equals to phone search results. My connection is not stable, so it might not work, but basically, once you do that, you will see all those columns, and then you will see, you come to this page and then map it out, right? All right, so for this particular tracker on the table, field 1 is used for snowplow domain user ID, field 2 is supposed to be win ID, and vice versa. And then the analytics team or analysts or data scientists will use this reference and then basically query this table and then use it in their dashboards, and then join different tables if they have to, and create a data set which is needed, right? Which is very, very ugly solution and really hard to navigate. So now that's why we are moving away from the solution, right? This is the backend solution. And also, yeah, I forgot. Snowplow had multiple iterations of implementation. So the very, very, very first implementation of Snowplow on the backend side was only for this 4 trackers. And then eventually we moved to a generic solution of stats tracker gem. But before we implemented stats tracker gem, the trackers and then the Snowplow framework itself was just embedded directly on the Spokio web app, which create very tightly coupled app. And then many times we have to change it. It was kind of a mess. And then also, if you want to create trackers from different services like DSS or vendor API, you have to replicate the same code on those apps. So then, I think back in the day, developers decided rather than embedding the code and coupling the apps with this framework tightly, let's just create this library so we can use this library on the different backend services like DSS, Spokio, vendor API, right? But before then, we had this implementation. And these 4 trackers are still there on the code base. And then also we have a epic to actually sunset Snowplow, and where we have draw the work to where is the code base, what to remove, how to remove it, how to test it, and without breaking the web app, right? And then all this is kind of following the same guideline from the Spokio web app, Rails side. It will push out the data directly to the Kinesis stream, the output stream, S3, and Lambda function, right? And that table, that data, that pipeline is pushing the data to another table called click tracking data, which is this. which is more, I would say, in detail rather than just having generic columns. But then you see custom dimensions coming in, which is part of Google Analytics, which is also another mess. So kind of to get away from this, we created this Stats Tracker gem using Snowplow, same framework. But now you can see there is another issue with this implementation. So then we decided to implement mParticle to collect our data. And we spent significant amount of time on, which is this, implementing mParticle. And we did months and months of data validation. We had huge plans with our CDP partner, which was mParticle, consumer data platform, that is. And we did a lot of validation, and we did not see the light at the end of the tunnel because there were a lot of the library issues which they had, and we found a lot of gaps, we found a lot of bugs, but after months of back and forth, we could not find any middle ground or a solution, which are some issues within their library. So we kind of decided to part our ways from mParticle. I won't go through this because this is already deprecated. The code is also eliminated. So then we decided to why use any open source or tools which are provided by somebody else and then rely on them rather than creating our own solution so that we can have more control over our own data collection, right? We can design it how we please, so that it's streamlined. It's very specific to Spokio's use case. And then when we have to change something, it would be easier for us to change it and then tweak it as well, rather than just relying on those frameworks and then do the patchwork, which we did previously to Lambda functions and then those generic tables, right? So that leads us to our final implementation of data collection, which is defined in this architecture, right? So again, same thing. We have two components: collecting data for front-end events, which is page views, clicks, form-related events, and then the back-end events, which are those stats tracker events, right? Where the payment has gone through or not, for example, if you want to notify when the search has started or not, for name search, for phone search, for different vendors. Basically, those are the back-end trackers. So for this particular part, we have divided we created two services, right? One is called Spokio Analytics, which is our NPM package, which is hosted on our NPM repo. And it's called Spokio Analytics. Basically, what it does is it is also part of our Spokio web app code base. And it is basically listeners on the page views, on the browser events, right? For clicks, for page views, for form related events, like for example, form submission completed or form failures when you do something, and if you missed a validation, then we will also capture that to figure out what is causing the users to drop probably from that funnel, right? So those kind of events are captured through this JavaScript NPM package called Spokio Analytics. Once it collects the data, it pushes that data out into the API service, right? Which is a gateway service, API gateway service on AWS. It validates the incoming request body. If the mandatory fields are not presented in the payload or in the put call made by this NPM package, we will reject it. For example, mandatory fields are domain, event name, because those two are later on be used for the partitioning scheme, and then the other two are session ID and client ID, because without those two particular fields, the data we collect are useless because we cannot map it to any clients or anything, right? So once the API accepts the data, it will then, it has an inbuilt integration with the Kinesis input stream, right? So it will push out the data to input stream. Now input stream will, again, buffer that data or bash the data, and then push it out onto the output stream. When the output stream receives the data, within the output stream, we have configured to deaggregate the bash data with the input stream, because remember, we are pushing, input stream is bashing all kind of different front-end events, right? Page views, clicks, form related events, which would have different schema. So we are deaggregating all those JSON, like on the output stream. And this is all part of configuration. We are not using Lambda function for this. So basically it will deaggregate the JSON, bash JSON. It will look for domain as well as the event name keys within those JSON, right? And then it will, when it is going to write onto our S3 bucket, which is our hosting area for our data lake, or Delta Lake, if you want to call it, it will basically create partitions based on the domain name, because we want to keep the domain level data separate, because we have Spokeo.com, we have peoplewin.com, we have thatstem.com, we have SpokeAnalytics.com, and then we have a few other domains which we own. So that we want to keep that data separate on S3. So it will create the partitioning based on domain. And then we also want to keep the data for each event separate. So it will, within those domains, it will create partition for its event name based on the event name, for example, page viewed, element clicked, form submission, form failure, right? And it will store the data on the S3. Now, if this parsing of the JSON or aggregation of the JSON resolves into any error, then there is a provision on the output stream to push that data out into the error directory, right? So this is the copper layer storage for errors. Basically, it will push that those erroneous events or batch data into this particular directory. And then also we have a generic backup. Regardless of errors or a successful process, we are going to keep the raw form of the data into this particular S3 directory, where we don't have domain or event level partition, right? It's just all just batched events. And then within this document, you can actually see how do we do the partitioning, right? For the raw data, you can see there is the prod bucket, copper data raw domain, which is the key I talked about, domain name, for example, Spokeo or Spokeo affiliates or peoplewin or something else. Then we are adding a client-side trackers, which is the type of the tracker, basically, or not the type of the tracker, but where the data tracker has been collected. So client-side tracker, and then the event name. This would be the page viewed or element clicked or form submission, form failure, and then normal Hive kind of partition, year, month, and date, right? On the backup side, we have only year, month, and date, because we are not doing parsing or any kind of other things on that. It's just bash backup data. And then on the error caused by any issues, for example, the dynamic partitioning, basically, when we parse the domain name and event name, that's what we call dynamic partitioning. And majority of the errors you might see in the future will be caused by the dynamic partitioning issue, where the domain was not presented in the incoming scheme, or event name is not present in the incoming data, or something like that, right? So it will create the directory based on year, month, and date, but then it also creates a directory for the failure type, which is the error message itself. So it will be easier for you to look for that particular failure. You will actually see when you are looking through the error, what kind of failure you're looking at, and then how to resolve it, right? Hopefully. And then this is the whole process of, this should have been a sequence diagram, but I didn't have the time to create a sequence diagram. So this is just a wordly representation of sequence diagram, basically end-to-end example when Spokeo user visits Spokeo domain app, right? From there, what happens behind the curtain on the NPM package, within the Salsa, within all the AWS services, right? It has a thorough example of end-to-end, and then until it goes into our S3 directory. Similarly, now we have our backend events or backend trackers, which we call Stats Tracker. We are using Stats Tracker gem, the same gem we talked about, but it has different module and namespace for the Spokeo Analytics Tracker. Basically, it will for example, when the Spokeo user comes to the Spokeo app, and then they start a search, right? There is a controller within the Spokeo which will be responsible to handle that particular request, which is coming from Salsa. And then from there, it will create a tracker. If the developer has added a tracker logic there using the Stats Tracker gem, right? And then it will push it out in the bash manner again batch of 3. I think the batch sizes has been increased to 4. But yeah, when there are 4 trackers has been accumulated in the batch, it will just push it out to the input stream. And then within same way, it will push out to the output stream, the same logic we have in the output stream and same configuration in the output stream to deaggregate the data batched events coming from the input stream, parse them, and then create the valid partition based on event name. We don't have domain partition for the backend trackers or server-side trackers because none of the other services like PeopleWin or Spokio Analytics are using backend tracking. So in the future, if we need it, we can add it. It's very easy, but as of now, we don't need it, so we haven't added it there. And same logic to store the data for the error part, for the backup files, and then for the process data. Right now, there is the reason why we are using Stats Tracker to collect the backend trackers, right, or server-side trackers, is so that we can use the same library within different Spokio backend services, like for example, DSS and then vendor API, right? So within this flow, so when you search, for example, for a name, we will check our cache. If we have that record in the cache, we will just pull it out. Otherwise, we will go to DSS, right? DSS will do the same thing. It will see if we have that record in the cache. If it has, it will just return the record to Spokio Web App. From Web App, it will go to the front end, and then it will be rendered there. But now, if DSS doesn't have it in the cache, we'll call the vendor API. Vendor API will decide whether we should make a live call or not, which is LexisNexis or any other vendors which we are using. Right, and based on that, once it gets the data, vendor API will go back to the DSS, same flow of Web App, and go to the front end for users to see the page on the page. Now, within this flow, there could be other trackers which analytics wanted. So that developer has added those tracker logic or tracker creation logic on DSS, which is an API service. So resources or vendor API resources, right? But it does the same thing. And it will create a tracker using the Stats Tracker gem, and then push it out to directly on the input stream. Again, we don't need the API service for this because there is no need to use that. We can just simply use an SDK, Ruby SDK to do this. And also we have on the backend side, the data is very curated, not curated, I would say very well governed, right? And we already know what we are pushing out. On the front side, we are using API to put some safeguards against it, because obviously anyone can push out anything on the using JavaScript can push it out on the API service or any other services on AWS client, so that we have API service, so that we can validate your request body and reject it with particular valid response code. So when a user or when a developer is actually pushing out something on the API service using the Spokio Analytics package, they would know there is an issue and this data will not land into the data lake. So they can then try to find a workaround, fix it, and then make sure that the data is ending up in the data lake, right? Similar way, on this documentation, we have talked about the partitioning scheme. As you can see, there is no domain key here because we are just doing event level data partitioning, right? For the backup and error directory, it is just the same. No changes there. But then again, there should have been a sequence diagram, but it's a wordly explanation of sequence diagram where end-to-end example, when a Spokio user comes in, what happens from there, behind the curtain on AWS side, processing side on the output stream, right? And then final destination on the S3.
Awesome. Do you have more to say about this?
No, I think that, yeah, this is pretty much all.
Maybe the next part, maybe you can talk about the Delta Lake, bronze, silver, gold, and kind of like the step forward.
Sure. So the next part is once we collected and ingest the data, then it comes to the hosting part, right? Which is data engineering part. We go to the pipeline architecture. So you can see mParticle. I'm going to change this today or tomorrow. You can disregard this mParticle part. You can just assume this mParticle data, which is Coppersite, is now our own collection there's very simple changes I'm gonna make it. But basically, this is Spokio Analytics package or Stats Tracker Gem, right? Basically, it's pushing out the data onto the S3 location, which we saw. And then from that, it's a raw JSON format, right, in a partition manner. And then once we get that data, we are going to use Databricks, and then we will create bronze layer. So the generic idea about this, there's different layers: bronze, silver, there's a copper, bronze, silver, and gold. Is copper is a very raw form of our data, right? It's just basically, you can assume it as a dumping ground. We collect the data, ingest it, and just dump it without doing anything other than partitioning, of course. Then bronze comes in. Bronze is where we actually gonna read the data and the copper from the copper, right? We're gonna do some kind of deduplication based on the event ID, and some other identifier if we have it in this in the data collected, and then we're gonna deduplicate it and then create delta tables basically. So delta tables are the data is still stored in the Parquet manner, right? Data is stored in the Parquet with the delta logs. So basically, you can query them using Databricks SQL, Spark SQL on Databricks or PySpark or Scala or any other language you prefer. But basically, you can query them against like a SQL table, right? But the underlying schema or underlying data will be in Parquet. And then the transaction logs are delta, so that's why they call it Delta Lake, or we call it Delta Lake now. And then the other part, I forgot, the Spokio Web App databases. The future part, the future requirement is to bring our Spokio Web App databases. For example, Spokio creates a lot of different tables, right? They create subscription tables, they create cancellations or payments or users. Obviously, we won't bring the table as it is, but we will sanitize those tables and bring in and make it part of our data lake. Whether it will be on bronze or directly on the silver, it is part of a debate as of now. But our goal is to bring everything in the data lake and eliminate everything else so that analysts and data scientists doesn't have to go anywhere else other than the data lake to find any data they want to look at, right? Yeah, so basically, once we reach the bronze, data here will be in Parquet format. And then there will be delta tables created for them, which is just logical tables governed by Unity catalog, right? The Metastore plus catalog is basically this catalog. If we will have time, we'll go into the catalog a little bit more on the UI. But basically, yeah, so that's what we do on the bronze part. Once we have data in the bronze layer, right, we will create more refined tables on silver side. So now when we are creating silver tables for front end, back end, and any other back end databases, right, we will sanitize the data. I mean, data collected, the data we collected from front end and back end it's been already sanitized, but if any further sanitization is needed, we will do it here, as well as we will do data type enforcement, right? We will also make sure that there is a defined schema of the table so that we don't just randomly add anything which we collect from from our collection framework, as well as in the bronze side. We are not doing any schema enforcements because we want to have a raw copy in the Parquet format and in a deduplicated manner, right? But on silver, we don't want it will be a little bit more governed, right? Where we are enforcing the schema, data types. So anytime we are adding a new data attribute, event attribute, for example, for page view, we are adding bot or isBot flag, right? It will land in the bronze layer, but it will not go automatically into silver. We will have to update the script or how we are enforcing the schema, basically that mapping. We have to update and add that particular field into the schema, JSON schema, so that when this job runs, it will add that particular newly added attribute isBot, right? And then write it out into the Parquet files as well. And then we will update the catalog so that the analysts, when they look at the catalog, they will know that, all right, this field is part of this particular table now. Out of the silver, after that, we have gold. Gold is more for the data analytics and data science part. So once we have silver layer, data is up and ready for the data scientist and data analyst to just go and then query and use it for production work, right? So for example, if they're creating fraud detection dashboard, right? Just an example. So now they are using all the data we have in the silver layer, and then they will create smaller data sets or final table by joining multiple tables, and then create a final table, right? And then write it out onto this particular gold layer, which is all this, by the way, is a separate directory on the same bucket, right? Copper directory, bronze directory, silver directory, gold directory under the same bucket. So it's all logical partition. Yeah, so they will write the data into the gold directory in a particular manner how they want, right? Using PySpark or SQL, Spark SQL or anything, but within Databricks. And they will write it out, and then we want to obviously connect those final data sets to Tableau dashboard or any other BI tool in the future. As of now, it's just Tableau. So what we can do, Databricks offers, since Tableau cannot connect directly to S3 bucket or Parquet files, right? It cannot read it from there as of now. Maybe future they can. So we have to, Databricks offers SQL, not Spark SQL, there is a separate module called SQL on Databricks. Basically what it does is it spin ups a cluster, right? And then you will connect that Tableau dashboard to that cluster, which is the serverless service, basically that, and then it will be able to read the data, right, as you can see here, from the gold S3 bucket, and then your dashboards can then, from the cluster, can just project that analysis on your dashboard. The other part is, other solution or workaround is, we still keep on pushing the final data set into the into Redshift, because Tableau has a direct connection to Redshift. And it's also a tabular relational database, right? Still a relational database, data warehouse, but still it's relational. So Tableau dashboard can directly connect to Redshift and then simply use that data and then project your analysis. So that's our basically, oh yeah, and then the notification part, of course. Notification part is when your notebook or your scheduled job on Databricks has failed for some logic issue or any other issues on the provisioning side. It will send out an email notification to the group you have set while creating the job or scheduling the job. And then you can also, we haven't done this yet, but you can also create Slack hooks basically, and then it will push out the notifications onto your Slack channel. And this is all the pipelining work, but how do we orchestrate this, right? So as you can see, we are still deciding what to use on orchestration, right? We can either use Airflow or just go with the Databricks feature called Jobs or Workflow. That's what they call it, which is very similar to Airflow, where you can create smaller tasks, right? Each task can be a notebook, and then you can also create a dependency between each task within a job, right? So for example, the first notebook will be runs bronze, first task, and within a job will be running a bronze notebook, right? After that, you can say, once the bronze notebook is done, I want to run silver as soon as bronze has done, finish its processing. So you can create that dependency within that task or that workflow. And yeah, so that's why we are currently using Jobs, but Databricks also supports Airflow. So in the future, if you want to use Airflow, we can use that as well. Yeah, that is the generic idea of our future architecture for data collection, data ingestion, and this is the hosting part of it.
Awesome. Well, we have about 9 minutes left, 8 minutes left. Do you want to go back to the onboarding and see if there's anything else you want to highlight, or is there anything else on the top of your head you want to highlight?
There are some processes which we manage, like for example, URL page categorization, analytics variables, but those are all very well documented. So let me see if I can find something which is probably not documented. very well. Yeah, one thing which is not documented here is anywhere maybe is how do we whenever we add an attribute, for example, on page view. Earlier in example, I said if you page viewed has a new attribute called isBot, right? What is the whole process, like end-to-end process for it? So maybe I can just talk about that a little bit, right? On the backend side, so the starting part is analytics context service, right? Which is basically been called from the base controller or Spokio controller now. And it's been available throughout the web app or all the controllers on the Spokio web app, right? So for example, we want to add isBot variable into the onto that event. So how we should do it, basically, we should start with the context analytics context service. Basically, this is the backend service which runs on the Ruby side. Not even a service, but basically a backend module where we are gathering all the analytics information, right? This is all everything which we are collecting from the backend. And then at the end, what we're doing is we are exposing that particular context hash, right? Which is this hash which we have created here, into Spokio context temp, which is a JavaScript variable, right? When you use window.spokio.context temp, where also it's been encoded in base64. Once this has been exposed to the web app, our Spokio analytics package, which is here, this is the code base, right? This will actually go in and then read the context and then push it out on the data layer. There's a lot of coding here. It will be probably hard to go through it, but there is a documentation on new context, which is, I think, also part of the onboarding document. But this is how this code base, the analytics code base, this whole document explains how does it get injected into the web app, how it's been used, how to publish it, right? How to maintain the code, how to maintain versions as well, how to debug, how to test it out, basically everything. But yeah, so basically once you add, for example, isBot there, it will expose a context temp variable. And then this particular package is responsible to read it and then library context. This is the initial context. Basically, it will take out the client-side data, client-side data, and then server data. Server data is basically that hash which we saw, right? As you can see here, which is decoding that context temp. And if it's not available, then context. It will resolve it or decode it and then combine it and then push it out. And this particular initial context will be part of our data layer, as you can see here, windows.datalayer.push. I'll go to spokio.com real quick. You will see all those variables on the context hash here, as well as some client-side data. For example, we cannot determine client's time zone, right? So we have to do that on the client side or on the JavaScript part. They're similar. We want to see event stamp. We want to have an accurate event stamp. So it has to go on the JavaScript part. Basically, there are 3 or 4 variables which has to be collected through the client side part, which is basically this, like data, which are this particular 4 variables, right? But the generic pattern of this, our front-end data collection, is anything which we want to add. First, we have to, or it must go into the context, because backend data collected from the backend is more reliable, right? And then the pattern is once you expose it from here, you will then go up in the ladder and then go into the Spokio analytics service, and then basically add it. And this is also TypeScript, so you have to define the type. You have to update the TypeScript as well.
And while we at it, if you go back to Spokeo.com to the website and you go to the console,
Okay, yeah.
yeah. If you type in the console Spokeo Analytics, capital S, Spokeo Analytics dot resolve, um,
Mhm.
that resolve, it's no Spokeo Analytics. Yeah. You need to do a tab on the
Yeah, it's just
that resolve. It's a function.
Yeah.
Then you can see also what is actually being sent.
Yeah.
It's also useful.
Yes, it is also part of that documentation part. Yeah. But yeah, so yeah, it's the same thing. Basically, that will not have those client-side events, I believe, right? Time zone, I believe time zone will not be part of this because this is just the context. But when you see data layer, it will be combined of that time zone and all that for all those 4 variables which we have added from the JavaScript part. And then when you go into Spokeo Analytics, there are a bunch of things you have to update, right? If it is just basically for one particular event, for all the events, you will add it over here, right? For example, some things, for example, event timestamp. You will not get that timestamp until that event itself occurs, right? So you have to add that particular variable on each of the event. As you can see over here, client date time. So when that event occurs, we will collect that timestamp and then pass it along that when we are reporting that event from that observer. And then the rest of the part is report to Delta Lake, which is also very important, right? This is where we are actually kind of constantly listening to our local storage, where we are pushing all the events, right? Whenever an event occurs, basically we just push that event into local storage. And there's a loop here. Basically, it will use that local storage as a cache, and then as soon as something lands in there, it's gonna push it out onto our API gateway from here. And then it will be landing into our Delta Lake. And very, very essential part, I forgot, that domain key, which we talked about earlier, right? It is part of Salsa. So Spokeo Analytics is a package we use on Spokeo, but it also being used into Spokeo Analytics, Spokeo Affiliates, PeopleWin, that's them as a standalone script, right? So there is a script in the analytics part, which actually creates a standalone script of this whole package, right? Get alone script. This is what it is. So when, for example, when peoplewin.com, you go there, it will call Spokeo assets and then this particular asset, and it will basically compile all this code into a single JavaScript and then serve it on those apps so that we can collect those events, right? So let me just quickly go through that.
Whereas in Spokeo, it's a hashed version of the analytics, which is part of our assets pipeline build. So we have that hash, but we don't have it for Compass Blog or for PeopleWin or for other sites like that.
Yes, but we are now. So I was just talking to a developer earlier, and also Mike has also emphasized that this is not right. There should be an underscore. But basically, this is why it's failing. Okay, I found the issue. But yeah, so basically we are asking the developers who are working on this different domains which Spokeo owns to have a Spokeo context or context temp, and then have that whole similar flow so that at least the Spokeo analytic, that standalone script can read the context itself, and then we are collecting data from the backend rather than the front end. Standalone script, right? But you can see there is no domain here, right? Even if you go to Spokeo and then look at the data layer or Spokeo context itself, you resolve it and see there is no domain. So how we determine the domain? We determine from Salsa. So whenever you make a call to our that API gateway, we have made it generic or random, I would say, a /t call. That's what we call it, because sometimes ad blockers can detect words within your API call, and then see if it has analytics or data collection or anything, it will block it. So to find a workaround, we say, all right, let's just give it a very random name, so no one can even figure out what is that. So /t calls, basically /t calls will be made from that standalone script, but now On Spokio side, we have Salsa, right? Between browser and server, we have Salsa in place. So Salsa gets all the calls from the server, from the browser, and then it reroutes to the web application. Whereas on the PeopleWin, Detstem, any of the web app, we don't have Salsa. So when we are implementing this on these apps, they have to, on their web app, on the backend side, they have to reroute or proxy the /t calls to Spokio /t, right? So there's the first proxy right there. When they do that, it will be a course call, cross-domain, cross-origin request, something. You know, I don't even recall the name, acronym. But when that happens, we go into the Salsa code base, and there is a router. And from that router, basically, we proxy that /t call. We used to be part of middleware, but not anymore. We don't want to have it in middleware. Oh, sorry, middleware. Sorry, it was part of rewrite, but now it's in router. Okay, so yeah, as you can see, it has plenty of comments, but in order to make this course request for /t, we are saying put in options are allowed method, and other headers to make it valid course request, right, from /t basically. Once that happens, the first call is option, very technical. First is option, second is put, the actual call. So when that happens, and here we will extract the domain from either the origin header. So for all the course request, origin header is must. You cannot, they cannot omit the origin header. And then for any other non-course, we are just taking out it from refer. Refer because for every request which comes to Salsa, if it is not the course, and it will be Spokio, because kind of hard to explain, but it's like kind of from browser to Salsa. So your refer is also always Spokio for non-course requests, right? So that's why the backup or fallback is refer, because for non-course, origin is an optional header. So that's why we are using refer. So when there is no origin header available, we will just simply extract it from refer, and those will be mostly Spokio, Spokio itself. And then we will add that domain, right, within the payload, request body payload, as you can see here. And then push it out. And then there is plenty of request error handling if while we are extracting the domain and the domain comes out empty, you can see these errors on New Relic, which is a lot of issues which are facing on the PeopleWin or some Detstem or something like that, right? We are seeing these errors on New Relic. And we can immediately figure out, like, all right, there's some issue within either the origin or some issue within domain name extraction. So this is the thing which is not documented anywhere, and must be very, it's very, very important for other domains which are not Spokio, because this is kind of behind the curtain, and it's really hard to figure out if your requests are failing, basically, if you're getting 400 on those sites. But yeah, this is the only part where we are touching Salsa. From data collection perspective, everything else is just as always on the Spokio Analytics package.
Awesome. We are out of time. Any final words here to wrap it up?
Nothing. I just wish good luck for the next developer to maintain. Yeah, reach out to me.
Thank you very much for your knowledge sharing and for everything you did. All right, let me stop the recording here.